And like Mr. St. Verignon, Freebody Diagram, this is one of those things that you should remember for the rest of your life, okay? So let's do that. I'm going to introduce the concept through an example. Let's say you have a problem like this. Okay, so you have a structure that is subjected to these loads. It is connected at this point to a pin that is holding it in place, and then something like this is holding it in place at point A. So you wanted to find the, let's see, let me label these first. This is 0.24 meters, and this is 0.18 meters, okay? So you wanted to build this structure to keep it nicely in shape. You know this is handling two forces of 240 Newton position like this. So you wanted to find a cable or something to hold this in place. You didn't have anything, so you found a piece of crap metal or something. You know, said, okay, this is gonna do the job. I'll just connect it here and here. So let's look at this problem first. Following the same procedure, step by step, to see how we are going to solve for the unknowns, right? We said, if you want to find all the unknown external reaction forces, step one, right, is what? Draw X and Y coordinates. Step two is what? Remove all the supports, put back all the forces known and unknown. Draw the Freebody Diagram. Okay? So that's what we're going to do. I will remove this. How many unknowns does this represent? Two. So that AY, AX. How about this one? How many unknowns? How many forces? Two. Okay, so what was the next step? Equations of equilibrium. How many equations of equilibrium do you have? Three. How many unknowns do you have here? Can we solve for all the four unknowns? We can, right? Well, that brings us to introducing a concept, which is, as I said, very important. And I'm sure, knowing you, you will promise me to remember that the rest of your life, even if I'm dead, okay? So, let's do this. Let's consider a piece or a segment of a structure that can look like anything, right? As long as that piece has these three attributes, okay? The three attributes being, it is connected to the rest of the structure only at its ends. In other words, you don't have another piece connected anywhere along this member. Number one. Number two, the end connections are pins. You cannot have that point, for instance, fixed to the wall or fixed to the rest of the structure. It has to be a pin. And criteria or attribute number 3, no load acts along this member. If these 3 are true, let's see what happens, okay? This is pinned, this is pinned. In other words, if this structure was connected to the rest like this, right? Let's look at its Freebody diagram. This means how many unknowns? I would remove it, right? Represents 2 unknowns, right? How about that one? Represents how many unknowns? 2. So what I will do to make my life easier, I would replace these 2 unknowns or these 2 forces with their resultant. Okay? Can I do that?
So do you just put the 2 forces that you put in, do you put them opposite of each other?
No.
Like
Right, doesn't matter, whatever.
Okay.
But you know there are 2 unknowns here, 2 unknowns there. That's all I know, right? Because they are pins. So what I'm going to do, I will replace this and this with its resultant, right? I can do that. Same thing here. I can replace these 2 with a resultant of these 2. Let me call this F1, call this F2. So far, so good, right? No problem. Then I do this. I will draw a line that connects, a straight line that, let me move this a little bit, make it a little bit like this so that I have room here. So let's say, so this was this other force, F2. So I'm going to connect these 2 points with a straight line that connects them, connects, say, A to B. And then I would resolve these forces along this line and a line perpendicular to it. I can do that, right? Can I? I can do it, right? St. Verignon. Remember Mr. Verignon. So I would replace these 2. I call this, let's say if this is X and this is Y, I call this F2X, this would be F2Y, and if I resolve that, this would be F2Y, F2X. I haven't made any changes, right? But now, this is the free body diagram of that piece, right? So I will start with summation of moments about A is equal to 0. What do I have? Can you help me write that equation? Anybody? If let's say this distance, vertical distance between these 2 is, say, D. This is straight distance. Okay, so what would be this equation? Anyone? Summation of moments about A. Say it loud. F2y times D, what else? That's it, right? Equal to 0. What does that mean then? That resolves in what? F2y must be 0, right? So next equation of equilibrium, summation of forces along y is equal to 0. That'll give me F2y plus F1y is 0. This is 0, so this means what? F1y is also 0. So the only equation left is summation of forces along x equal to 0. And if you apply that, you can easily see that this would be, I call both of them 2, right? This is 1 and this is 1. It would give us F1x is equal to F2x. What does that mean? That means if you have a piece of a structure that follows these criteria, the only way this piece can be in equilibrium or satisfy equilibrium conditions is that there's only one force acting on this structure. Or in other words, two forces equal in magnitude, opposite in direction at the two ends. And these forces have to act along a straight line connecting these two ends. So regardless of the shape of that piece, no matter how it looks, you always have forces that act at the two ends, acting along a straight line, connecting the two, and these two forces are equal. So this member represents one unknown force and not two. So going back to that example, what that means is you have a member, you see this member now? Pin connected here, pin connected there. There is no other member or any piece connected along this member anywhere. And there is no load acting along this. In other words, for instance, you don't have a force like this acting on this. There is no load. That means all this represents is that it represents a force, okay? That if you remove this, a force that is acting like this and like this here, and they're both equal. F, B. Okay? So that structure is only subjected through three unknowns. As you, yes?
And there's no moment applied, just the force?
Just a force. I mean, you remove this piece, based on what we discussed, represents only a single force that acts along the line connecting the two ends. If this was a straight member, obviously it would be along the member, but doesn't have to be. Regardless of the shape, as long as the two ends are pinned, this force acts along a straight line connecting these two ends, and these two forces are the same. This is a concept that you really need to remember, be good at it, because as you will see, all the structures that you will be studying later, trusses, frames. In case of frames, you may have frames that have several two-force members. In trusses, every single member is a two-force member. So you really need to learn this by heart, and you will become very good at it. So now the problem is easy, right? We can move on to step 3. And step 3 is what? Equations of equilibrium, right? And I will go here. So I can write summation of moments about a point where two unknowns intersect, and that point would be C is equal to 0. But remember the three things that you always remember. Same varigon, Freebody diagram, two force members. That's it. Not much. Okay? So you SV, FBD, right? And what else? Three things. Three of them. Number 1, same varigon. Number 2, FBD. Number 3, 2FM, right? That's it. TFM, or whatever you want to abbreviate it. So that means I would resolve this to its components. The slope here, given this point 18, this point 24, would be 3, 4, 5. So this would be 4/5 of FB. This is 3/5 FB. So if I take summation of moment about point C, This goes through that point, doesn't generate a moment. This will generate a clockwise moment that is negative, distance is 0.18. So you have 4/5 FB times 0.18. This is negative. Each of these also generate a negative moment about point C. This one, 240 times 0.4, so you have negative 240 times 0.4, and negative 240 times, 0.4, 0.8 equal to 0. Solve for the unknown FB. FB results to be negative, a negative value, 2,000 pounds, 2,000 Newton. Negative means what? The assumed direction was wrong, so I would correct this. The assumed direction should have been like this, okay? So now that I've corrected it, remove this, this is the answer. Then I go ahead with the other two equations of equilibrium. Summation of forces along x is equal to 0. You have negative 4/5 times FB, which is 2,000 Newton, plus CX is equal to 0. That'll give me CX that's equal to 1,600 Newton, and acts in this direction. Okay? Okay, and then summation of forces along y is equal to 0. You have CY minus 240 minus 240 minus 3/5 FB, or minus 3/5 of 2,000 equal to 0. That will be giving me 1680. CY is 61680 Newton, and it is acting in this direction. Okay. Any questions? Easy, right? Yes.
Where did 2,000 come from again?
I saw this.
Oh, from
Right,
FD. Oh, okay.
yes, from Summation of Moments. Okay. Any questions? Any other questions, confusions, ambiguities, whatever? No? All right. All right, so let's do another problem. Okay. So let me erase this. Okay, so let's do another interesting problem. So I better shut this off. This is 712. So you have a structure that looks like this, sort of an L-shaped beam or channel or something like that. It is connected to a pin at a point D, 3 inches from the top, okay? 12 inches here. At this point, it is subjected to a force P, which is given 90 pounds. Obviously, this structure is not stable, so what we will do, we will attach, and this is, by the way, 7 inches. Attach a cable here that goes around a pulley at this point and comes around and it's attached to this end. Let me label these A, B, E, D, C, okay? And again, what you've been asked is to find the unknowns or the reaction forces that support reaction forces that hold this structure in place, okay? So let's look at this again. Step one. Okay, XY coordinates, so I would set up an XY coordinate. Step two, cut the structure from all its supports, right? Remember from physics, if you had a pulley, frictionless, with a cable going around it, no matter what the orientation of these two cables are, force on the two sides are the same. In other words, there is the same force that acts in that cable here and here. How about here? If I remove this, that represents two unknowns. Let's assume these two unknowns are this way and this way. Okay? So that is the free body diagram, right? Step number 2. Step 3, apply equations of equilibrium. Equations of equilibrium.
So on the homework, is it okay if we just change the figure into free body diagram like you were doing?
It's better. It's a better habit to do the free body diagram separately. I just want, to be honest, to save some time here.
Okay, yeah.
But it's better to draw a free body diagram, especially on the exam also. Any other questions? So, remember, don't ever forget saying very done. So you have to resolve this. The orientation of this is what? This is, oh, this distance is also given. I forgot to give it to you. That was, I believe, that was 5 inches. So this is 5 inches. So this would be 5, 15, or 3, 1, square root 10. That's the slope. So you resolve this into its components. That means this would be, this component would be 3 over square root 10t. This would be 1 over square root 10t. Okay. Now, let's write equations of equilibrium, starting with summation of moments equal to 0, about a point where two unknowns intersect. So get rid of them, and that point here would be D, so that's summation of moments. So take summation of moment about D. This force makes a moment counterclockwise, 9D times this moment arm 12, positive. This one, the same about point D, makes a counterclockwise or positive moment, so you have T times 3. This one makes a negative moment because it turns clockwise about point D, so that will be negative 3 over square root 10 t times this distance 7 inch. Okay, and so this one does this one. Also clockwise, this is the vertical distance, so it would be negative 1 square root t times 12 equal to 0. If you solve for the unknown here, you'll see that t comes out as 145 pounds, and the assumed direction is correct because it turns out to be positive. Any questions? Okay, so you move on with the next. That would be summation of forces along X or Y. I will choose summation of forces along X equal to 0. So that will give you negative dx, positive 90 this way, negative t, or negative 145 pounds, and negative 1 over square root 10 times 145 equal to 0. That will give you dx that, in fact, results to be, okay, if I, 101 pounds negative. If you solve for that, parameter, it comes out, the x comes out to be negative. That means the assumed direction here is wrong, so you have to change this, which means, of course, you have to change this as well, right? So that would then be just 101 pound acting in this direction.
So like on our tests and stuff, you want us to like go back on the?
You need to, because otherwise, if you don't change that, the next one will also be wrong. When these is not a big problem, but as you see when we get to internal forces, especially with the frames, immediately the first negative one that you come across, you have to change it so we would stay consistent.
Okay.
Consistent, because these pieces are connected together, there's action and reaction, so if you don't change, you have to change the force on this component so that you would have also the opposite one on the other one. We'll see that, but yes, the short answer is yes, you have to. Okay. And then summation of forces along y being 0, you have 3 square root 10 this force times 145. I changed that, you remember? I changed this to negative now, dy, and that's all I have, is equal to 0, and dy results as 138 pounds downward. Okay. Any questions? No? You're good? Good? So let's do another problem. If you have any interesting problem in mind, you can give that to me. If you have already looked at the homework sets and something looks kind of challenging or interesting or confusing, whatever, I'll be happy to go over those. Oh, you have something? Oh, wait, you said it.
How about 3.121?
3121, let me, do you have that? The
Yeah.
description?
Yeah, I'm not sure if I did it.
3121. Oh, okay. That's a 3D, right?
Yeah.
Okay, we haven't discussed the 3D yet. How did I give you 3D for the homework? How many 3D you have?
There's that one.
You give us that one.
Oh, just that one?
Yeah.
Yeah, because I'm just going to start 3D on Monday.
Oh.
So, the concept is the same. Of course, summation of moments is equal to 0 summation of forces. But let's keep that for the next time. You have a 2D?
Should I
good?
not do that one?
No, I'll send an email. Just the 2D. That somehow got,
The trust one, 3.1 and 1.3.
oh, you want the reaction forces, not the, when you said trust, like you scared me
Oh,
at the
yeah.
start. Do you have the problem statement?
No. On my phone.
Yeah, I can see it. Okay, that's not a problem. That's okay. I can see it. So you have a problem that looks like this, right? No, I think it's clear. That's 8 feet, 8 feet here, right?
Yeah.
8 feet, 8 feet here. Okay, and then all of these are 8, so you have, okay, 8 feet here. So something like this. So you have 8 feet, 8 feet, 8 feet. The structure is supported by a roller at this end, labeled as A, and this is B, okay, okay, C, D, E, F, G. This is the support, and there's a force acting at 40 degrees right here, 300 pounds. Another force, 160 pounds here, and at 240, and this is 70 degrees. 240 at 70 degrees. That's it, I guess. Oh no, another force, 180 pounds. Okay? And the problem is asking you to find the reaction forces, right? Support reaction forces. Okay. Oops, sorry about that.
I don't think that one was the rule.
Must be.
I think it was switched. I think it was A was the pin and G was the rule.
A was this pin?
Yeah.
Doesn't matter.
I must have missed that.
That's okay, that's okay. I don't wanna just redraw it. Well, maybe I'll do that. Since, if you insist, although it's not gonna make a big difference. You have 3 unknowns, right? I did the same. I said I switch it. I'm very tired.
It's all right.
It's Friday, yes. That's okay. Step number 1, X and Y. Step number 2, free body diagram, right? But in order to do the free body diagram, first, remember Mr. Saint Verignon. So this would be 240 cosine 70, 240 sine 70. Same with this one, replace that with its components. So this is 300 cosine 40, this is 300 sine 40. And I know he's already calculated those. No?
Yeah.
What is 300 cosine 40?
May not have written them down.
Oh, so,
I just wrote them as like 300 sine 40 and then.
okay,
229.
all right, that's, okay. I thought you had already solved the problem and you had faced the difficulty and you were asking me to solve it. That's okay.
No,
That's okay.
I solved that, I just didn't write it down like as the number.
Okay, so what is 300 cosine of 40?
229.8.
229?
Yeah.
Great, okay, that's not bad. And 300 sine 40 should be about
93.
193.
192.8, but.
That's okay. Okay. And how about 240 sine 70?
225.
225. Okay. And 240 cosine 70?
82.
How much? 182?
82, yeah.
82? Terrific. Okay. Now we have better looking forces, okay? So, free body diagram, right? So we have those external forces. Remove this support, which represents how many unknowns? Direction of motion is this way, so you have only one unknown perpendicular to the direction of motion, or at A. How about this one? 2 in both X and Y direction, GX, GY. So this is the free body diagram. Any questions? I'm sure that's what you had, right? I didn't see free body diagram in your drawing.
It was separate.
Separate, oh, good, okay. All right. I thought you were going to surprise me or something. So, step number 3, write summation of moments about the point of intersection of two unknowns, so I'll write it about G, is equal to 0. Okay? And do you have this height also? I forgot to write that.
There's 6.
How much?
6.
6, okay, great. 6 feet. So, take moment of all these forces. You have 229 going this way, counterclockwise. So you have 229 times 6, moment of this force about this point. This guy, the distance is 4, also going counterclockwise. So you have 193 times 4 feet. How about this guy? This distance is 4 plus 8, 12, going also counterclockwise. So you have 160 times 12 feet. Same thing with this guy, counterclockwise. You have 225. Distance is 8, 816, and 420.
I think the problem asks for it at A.
Yeah.
Yeah, okay.
Only, yeah, that's what I'm finding.
Okay, okay.
And then moment of this force, this goes clockwise about G, right? So you have negative 82 times distance, vertical distance is 6 feet. And then this one also clockwise, so minus RA times 24 equal to 0. And that leads to RA, and that would be how much? Did you already find out?
RA, I calculated it based on the moment at A, but I got the moment A to be.
Moment at A, that'll give you GY. If you take summation of moments at A, you're eliminating this unknown. And this goes through that, so you'll be finding this guy,
Okay.
right?
Well,
So,
336.4.
how much?
Negative 336.
It comes out to be negative. I doubt it. Because these are all positive, this guy is negative, cannot be negative. So it comes out to be 334. I'll take that part. At least not based on my assumptions for those directions. They don't come out to be negative.
Does the 180 pound force at C
Oh.
not do anything?
See, it's Friday. We totally ignored that poor guy, 180. Where was this guy doing? So we have to take the moment of this guy and add it here. 180. Also, the good thing is also counterclockwise. So let me add that with a different color, right? 180. So I will not eliminate the sign of guilt. Okay? But according to the answer he gave me, this is it, right? 334 is based on all of those? Who gave me the answer? So you're still calculating. No, you gave me this answer, right? How much? 336.4.
That was without.
Oh, so you ignored 180 also. Oh, so that was my fault, of course. I'm not gonna-
It's 380.
How much?
380.
388?
Or just 380.
380. Okay, that's better. All right. At least let's have some fun. It's Friday.
Like, you just label RA, just like the roller at A? Is that what
It
you-
is a roll.
Okay, all right.
Yes. Any other question? No, you're looking at the clock. We still have 10 minutes, so I'm gonna do one more problem. Yes.
You get 89? I don't know. It's Friday.
Every time I'm calculating, I'm
Oh,
not
resulted of G4 seconds.
Yeah.
Yeah, right.
Oh, and then like, where do you put it?
See, this is the question actually apparently the
Oh, wait,
problem is asking.
16.
I just stopped here, right?
Wait, oh no.
You need to find also the other unknowns.
Professor Noori,
Yes.
456, we double check with each other.
Yeah, RA 456.
Triple check.
Who should I believe? Let's vote on that. 456? Okay, I'll go with
Think
yours.
engineers plugging numbers into
I give
calculators.
him my most positives.
456. Everybody agreed?
Yeah.
Okay. So now let's find GY, right? You have summation of forces along Y is 0. So you have GY minus 193 minus 180 before we forget that guy. Minus 160 minus 225 and plus 456 is equal to 0. So that will give you GY, whatever that comes out, and will be positive, so the assumed direction is correct. Okay? So, and summation, so while you're finding this, I'll do summation of forces along X because that's easy. You have negative GX, negative 229, then you have positive 82, right? Those are all forces, you have 0. So that would be GX comes out to be negative 147. That means the assumed direction here is not correct. So this should be this way. Okay, and we correct that, and that's it. Now you said the problem is actually asking you to find a point of intersection of this resultant with this line, right? Something like that?
Yeah, the line of action.
Right, of this force.
I think
It says a bar HE, right?
Yeah.
Doesn't it say the whole bar?
bar and the line of action.
Yeah.
Line of action of what?
On HE. Like on the axis HE.
Line of action of what force?
I think all the forces that are applied.
I think it's like a resultant.
So it's asking for the resultant. So you just find the resultant of all these, find the direction of that resultant.
Where do you put that though to find the point of intersection though? Like once you have the resultant? where do
You find the direction, right?
Uh-huh.
So it gives you the angle, so you know where that is.
But coming from where?
Well, you need to find the resultant. Find all summation of forces along X, summation of forces along Y, right? So you can put it, say, along the X-axis. That's it.
So you find like the magnitude of, right?
Right. You have all the forces, right? You find it, if a summation of force along X and Y, then the square root of sum of the squares, that will give you the magnitude
Would
of the
that
force.
just be 0 though? Because they're, both the sums are 0.
No. It's what you want to find is the resultant of what forces? What, it's very confusing. What is the exact,
Okay, so.
exact statement? Let me see.
I have it.
Okay, let me read the exact statement. And it doesn't seem to be a very interesting problem. Trust supports the loading shown, determine the equivalent force. So it's an equivalent force problem. It was not even the unequilibrium problem. So I was given, since I'm being videoed, I have to defend myself. The problem is not even asking for the support forces that you told me. It's only asking you to find the equivalent forces. Sum of, in other words, is not a rigid body equilibrium. It's not, but at least I turned that to an equilibrium problem, which is fine. It's only asking you to remove all these forces, applied forces, with a single force. And you know how to do it, right?
Yeah.
Replace all of them with a resultant, take, and you put it, say, at point A, and summation of the moments of those forces at point A, put it there. Okay, so I was hoping that you still have 3 minutes.
The part that was that I want to know how to do was how to put the intersection of line of action.
Yeah, it's that the type of problem we did that you know, you need to move the forces, right, to a point that you don't know where that point is, X, say from A, right? Then, since summation of all the moments have to be 0, right? So you take summation of moment about that point, you find X. You remember we did a problem like that?
It's like what? Moment
It's
over-
exactly like
moment
that.
over the force.
Right.
Oh, okay.
Right.
Alright.
Moment is like-
I will promise this would be quick. We will do it in 2 minutes.
Okay, yeah, that
It's
makes
a
sense.
good
What
problem.
the moment mean?
So we were sidetracked. I should have not asked you to give me a problem to
Okay,
solve.
and then just.
It had nothing to do with rigid body equilibrium. So let him feel the guilt, okay? For this guy. Don't harm this guy. Okay, 40, this is an interesting problem. At least, even if we cannot finish it, it's something that we can do the first 2 steps, which are the most important steps. Okay. So you have a structure that is loaded like this, and you want to find the unknown support reaction forces, okay? Step one. Step 1.
Axis.
Yes, X1. 2, Freebody diagram. So, in the interest of time, you have a roller here, always move it, so where would that force be? In directing where?
What?
Right, horizontally this way. So if I label these A, B, C, D, this would be R, D. How about here? You have a force that acts perpendicular to the potential direction of motion, and then force B right here. I will just tell you step 3, the first step of it. How about that? So you can do the rest. So if I write summation of moments equal to 0, I just want to start with that, okay? Although in this problem you don't have to, but I intentionally am doing that, okay? Where should I take the summation of moments so that I end up with only one unknown? Remember the concept, you take summation of moments about the point where 2 unknowns intersect. Do you see a point where 2 unknowns intersect here? You said it, yes. See, if you continue here, if I take summation of moments about point C, right? Get rid of these 2, you only have this one. So you just have RB, right? Which will be clockwise times 2 negative, right? And then you have also negative 40 times this, which is 2 meters, right? And then you have also that negative 20 Newton meter equal to 0. So that'll give you RB, which comes out to be negative, and then you will do the rest. Okay? Have a great weekend.